Good afternoon, ladies and gentlemen. Welcome to the ILIKA PLC half-year results investor presentation. Throughout this recorded meeting, attendees will be in listen-only mode. Questions are encouraged, can be submitted at any time using the Q&A tab situated on the right-hand corner of your screen. Just simply type in your questions at any time and press send. The company may not be in a position to answer every question it receives during today's meeting. However, the company can review all questions submitted today and will publish any responses on the Investor Meet Company platform. Before we begin, we'd like to submit the following poll, and I'm sure the company will be most grateful for your participation. I'd now like to hand over to CEO Graham Purdy. Good afternoon.
Thank you, Mark. Good afternoon to everybody who's taken the time to dial into this presentation. We really appreciate it, and we look forward to talking you through this update of ILIKA's progress. These are, in fact, our half-year results. So these are published at the halfway point through the current financial year. The halfway point was at the end of October 2023, and these are an update of the period, the 6-month period up to that end of month. So first of all, let me say that we intend to cover the full ILIKA story. Apologies to those of you who have been following the company for some time now. We will, because there are some new attendees who aren't quite so familiar, give the overview of the whole story, and we'll be covering all of the bases. And also giving a bit more insights into some of the specific progress that's been made in more recent months. So for those of you who are new, there are 2 product lines that ILIKA focuses on. We specialize in the development of solid-state batteries, so that's all that the company does. But on the one hand, we have our Stereax miniature cells that are primarily used to power miniature medical devices and industrial wireless sensors, sometimes referred to as industrial IoT. And then on the other hand, we have our Goliath large format cells for the automotive industry, and also for some cordless consumer appliances. Our EV batteries use an oxide electrolyte and a silicon anode, and I'll go into the competitive landscape and some of the materials choices in a bit more detail as we progress with the presentation. So we've got Jason and myself presenting today. Jason, please say hello.
Good afternoon, everybody. Welcome along.
Jason's now been with us for a year. He joined as CFO in January of 2023. And if you want more detail on Jason and myself, or the non-executive directors who are pictured here, please go to our website. All of their profiles are visible for you to peruse at your leisure. So first of all, a few words on the ILIKA business model. I'm going to let Jason talk you through this.
Thank you, Graham. And for those that are unfamiliar with the ILIKA story, we operate an asset-light licensing model, which is different from some of the other battery development companies you may have read about in the press or be following in the US as an example. So a number of those other companies are attempting to both develop the technology and then scale all the way to gigafactory themselves, which is a fairly substantial investment into the billions of pounds or dollars, depending on where they're based, and a really substantial investment from their shareholders to be able to bring that to market. And that also requires them to be masters of both the research, development, and the manufacturing processes required to get that gigafactory up and running at an efficient manner. At ILIKA, we've decided to take a slightly different approach. We recognize where our core skills lie, and that is in the research and development front. So we are going to pursue a model where we have the incumbent scientists to develop the technology. We will demonstrate that on production intent equipment, so to demonstrate that it can be manufactured on pieces of equipment that you would find in a gigafactory, albeit larger versions of those machines. But at that point, we would seek to enter into licensing agreements with partners so that we could then piggyback off their expertise from a manufacturing point of view, and also the fact that they are already part of that supply chain for either the medtech or the automotive environment, making that transition from R&D into mass market production that much easier. And that's very much the model that we've deployed with Cirtec over the last year.
Thanks, Jason. So first of all, a quick trot through progress for Stereax. So there's a bit of a healthcare revolution that's going on at the moment, and that's focused around the development of electroceuticals rather than pharmaceuticals, and typically relies on the use of smart devices to treat some of the debilitating conditions that might previously have been treated with what can be quite toxic drugs, with side effects that are not particularly wished for. So in order to use these miniature medical devices, they need to have certain properties that allow them to be effective for the therapy or the diagnostics application. First of all, they need to have a compact architecture that offers a higher energy density, so that the device is as small as possible. Secondly, they need to have an improved safety profile. The last thing you want as a patient is to have a risk of toxic fluid leakage. And then thirdly, they need to have a high power density. So what that means is that they're able to deliver pulses of power, usually either for the therapy or often to power a communication chip. So say a Bluetooth device that needs to be powered in order to send data to an external communication device, often a mobile phone. The applications are really exciting. Let's cover a few of these. First of all, probably the biggest market actually is smart orthopedics. And these are knee and hip replacements, and also some spinal surgery. And this is where you put these devices into the replacements, and you often monitor the movement or strain that the devices are seeing after the surgical intervention, and sending that data so that the patient can be coached in the physiotherapy that they're carrying out after the surgical intervention. Unfortunately, this is very much a growing market, with more and more people needing replacement joints, and therefore it's an interesting opportunity to enhance the capability and functionality of these knee and hip replacements. One of the applications that we often talk about is neuromodulation, or in fact neurostimulation. An example of this can be pain reduction, in which the nerves of the lower back are stimulated to block pain signals. Of course, lower back pain can be really debilitating, and again is a disease which is very prevalent, particularly in older people in mature Western economies. And so this represents an interesting application area. And then thirdly, perhaps one of the applications which is closest to market is smart orthodontics, where you put a sensor onto a retainer, sometimes called an aligner. And these sensors are not only used for ensuring that teeth are properly aligned, but also can be used in sensors that can trace biomarkers in saliva, and then help detect indicators of certain diseases. In terms of the order analysis that we've got in these sectors, first of all, we've got two pie charts here, one on the left, which is orders by application. So the majority relates to implanted medical applications. In addition, we've got about 12% for smart contact lenses, and then 13% for those smart dental or orthodontic applications. About a quarter of the orders relate to industrial IoT or industrial sensors. And these can be things like aero engines, condition monitoring in those applications. Then on the right-hand side, you see an order analysis by geography. About 3/4 of the orders relate to companies that are based in the US and about a quarter here in Europe. So that's one of the reasons why we wanted to have a strong footprint in the US to be able to have as short a supply chain as possible and to be able to be active close to the location of our customers. In terms of what that order book might develop into, I'm going to let Jason talk a bit about this commercial growth profile that we've got on slide 9.
So we have obviously achieved the signed licensing agreement with Cirtec over the last year, and Graham will touch just a little bit more on who they are and what they do in a moment, but wanted to give a little bit of more flavour as to how that would translate into the development of revenues on the Stereax side. So while we cannot give specific guidance around the numbers, we wanted to help people to have a better understanding of how the various layers of revenue would develop through on the Stereax side. So as you look on the left-hand side of the graph there, what you can see are the various different layers that we would expect to come through. Now, at the very bottom, there's a very small element of blue that's visible, and that represents in the short term that we will be manufacturing, will receive an outsourced manufacturing fee from the relationship, as we have retained what we call the tool one, the cathode deposition process, really the proprietary element of Stereax, the secret sauce, if you would like, and we will continue to operate that for the short-term future, just to ensure that that continues as in the best possible manner. But as a result, we will receive a small amount of revenue on the back of that. Ultimately, that would then transfer across to Cirtec. Building on top of that, we would then have what we expect to see coming through, which is non-recurring engineering fees. So this is where we would work with some of those customers that you can see on the table on the right-hand side, and they are seeking to use our expertise to validate the Stereax batteries in their particular application. Now, that may be in just a validation that it works for the pulse requirements or whatever application they're talking to, or for a larger fee that they would like us to develop the Stereax battery to a particular form, fit, or function to suit their particular need, whether that is in size or shape or power density for their particular requirements. And they would provide income to us to support that development activity. So we would derive revenue from that. Then obviously the larger section, the grey section you can see there, really is the development of the licensing income from the sale of the batteries that would come through. So that is the royalty rate that flows back to us from each battery sold. In the initial phases, while it's very low volume, that is a profit share, so a higher proportion of the income comes back to us. But then as we switch through volume and we start to see those batteries enter through the FDA approval process, we would expect that to become the bulk of the income from the Stereax product line, certainly as they grow and multiple products then achieve approval. And then the last element, those spikes that you can see on the top, really are an explanation that while we have a licensing agreement in place with Cirtec, that's a non-exclusive license really focused around the medtech sector, which is where Cirtec are specialists. So that has preserved the right for us to issue additional licenses in the future, either outside of that sector, if we get someone who comes from the industrial Internet of Things and wants to take a license for large-scale manufacture, or if we have really high volume manufacturing that is maybe beyond the capacity that Cirtec has or wants to go to, and that might need an additional license. Just to point out that the initial license that we've done with Cirtec had no upfront fee as a result of them taking on the cost and sharing the cost of development and scale up, and really the benefit that ILIKA derived from that was in cost avoidance, which you'll see when we get to the financial numbers at the back, where we've been able to reduce our cost burn by completing that tech transfer and outsourcing. And just on the right-hand side, really that's a reiteration of the customers that we have shown before. So no new news on the customer front, but just to reiterate that we are still in active discussions with all of these customers and not losing any of those. So we continue to discuss with them. And as I said, some of those are now developing into NRE type discussions about how we can further develop for their specific needs.
Thanks, Jason. So maybe a bit of an overview of where we are with Cirtec. So for those of you who don't know the company, they're an industry-leading, vertically integrated outsource partner for medical devices and components. So I would say that they're a tier one provider of sub-assemblies and technology platforms to the large brands, the large medical device companies. We see that this is a real validation, actually, of the Stereax product and process. And it's a partnership, actually, that offers an economy of scale through their ability to ramp production. They have a substantial facility in Lowell, Massachusetts, that, in fact, they're extending in order to accommodate the opportunity that ILIKA Stereax technology offers. And the additional benefit is that they have a substantial business development team with resources to be able to bring additional momentum to our own business development efforts. So the key equipment sets that we used on our initial manufacturing line have been transferred to Cirtec now, and that equipment set is being installed. Cirtec were working hard over the end of the year to make that happen, and commissioning is in process. They will carry out a series of acceptance tests with our support, and we will carry out a series of user acceptance tests once the equipment is operational, and then we'll run it through some qualification with a view to starting to deliver product towards the end of the year and into 2025. So that covers Cirtec and Stereax. Let's move on to Goliath, have a bit of a change of gear and talk about our large format EV batteries. Just to reiterate, actually, our large format EV batteries are made using a different process to the approach that we use for our Stereax miniature batteries. For the connoisseurs amongst you, the Stereax batteries are made using a thin film deposition process, a vacuum deposition process, which is extremely accurate and very effective, but actually too expensive to use for putting down the amounts of material that are required in order to store the energy that's necessary in order to power an EV. So we use a more conventional series of processes that start with powders that we turn into inks, and then we print the layers of the electrodes and the electrolyte and form a battery using a fairly standard set of processes that then give us the volume of battery material that's required. So actually, there's all sorts of advantages to using the ILIKA approach. We've got an oxide electrolyte and silicon anode architecture that offers a higher energy density. We've got an improved safety profile because the solid state electrolyte is less flammable than the normal liquid electrolyte that you get in incumbent lithium-ion batteries. We've got that higher energy density, reduced cell degradation, and what's becoming increasingly important is better recyclability, so that actually it's more straightforward to be able to recycle Goliath cells than the incumbent lithium-ion batteries that are out there. One of the dynamics of this market is that actually it is a regulatory driven opportunity. the EU's banned the sale of conventional vehicles by 2035, and other governments have made similar commitments. So that means that actually there's a very strong driver for EVs to be rolled out, and actually improving the performance of those EVs through the development of solid state battery technology like ILIKA is developing is absolutely key to supporting the acceptance of EV technology. That'll make a fantastic contribution to reduction of emissions. Like many countries in the West, actually, transportation accounts for a quarter of the CO2 emissions annually. So by deploying battery-powered vehicles, you make a massive environmental impact. But there are still reasons why people hesitate actually to purchase EVs. One of the principal ones is range anxiety. And actually, solid-state batteries go a long way towards addressing that anxiety, because the higher energy density of the cells themselves is augmented by the reduced engineering that's needed in order to ensure the safety of the packs. So when we talk about safe cells, actually we talk about the safety in the context of the engineering that's required in order to make the pack survive some of the vehicle tests that the vehicle is put through. So in the industry, they talk about the pole test, which is effectively a crash test. Normal vehicles are simulated wrapping themselves around a lamppost when you have a collision. And of course, there are crumple zones that are built into a normal vehicle in order to absorb that energy, that impact, in order to protect the passengers in the vehicle. With EVs, actually, those crumple zones are not quite the same. And so the packs have to be protected with substantial additional reinforcement for the safety of the passengers. With solid state, you can reduce the amount of engineering that needs to go into protecting the pack, because you haven't got the flammable liquid electrolyte that you have in a normal battery, and therefore that lightens the vehicle, and therefore actually that makes an additional contribution to the range of the vehicle with a given weight of batteries. So all sorts of range extension opportunities by using solid-state batteries. You also get an improvement in overall battery life, the recyclability of solid-state batteries means that you can do a lot towards promoting the circular economy. So our market entry point is going to be the top end of high volume vehicles. So let's call them luxury vehicles, because they are, in the first instance, slightly less price sensitive than mass-produced vehicles. There are other materials choices and cell choices you might make for entry-level, low-cost vehicles. A lot of the mass market Chinese vehicles might use a so-called LFP, or lithium iron phosphate chemistry, in order to make sure that the price point is kept low. Of course, you compromise performance by doing that, and by using solid state, we can address the performance issues that are required for higher end vehicles. On the right-hand side of this slide, you can see projections of EV sales actually to remain strong through the next few years towards the end of the decade. There have been some scaremongering headlines about perhaps appetite for EVs cooling off, but remember that regulatory driver for EVs is still very strong, and actually with the continued technology development, that we're seeing in the sector, including solid-state batteries, we expect uptake to be sustained. So where are we in terms of technology development and production scale-up? On the left-hand side, you see a summary of some of the great breakthroughs that we had just before the end of the year. So we announced that we had achieved our D4 data point, which is a design freeze data point that allows us to then productize our first prototype, our P1 prototype. We need a few months in order to fully characterize the D4 data point and make sure that the cells are fully understood and, of course, are safe and meet target specifications before they're sent out to customers. Hard on the heels of that announcement, we also announced the lithium-ion equivalence point had also been reached, which basically means that our solid-state cells have intersected the performance of traditional lithium-ion batteries and are now offering improvements relative to that benchmark. So the dark blue line that you see there is the trace of what's been achieved in terms of energy density by an average lithium-ion battery. And in fact, we expect that technology to continue improving, but into the zone of maximum theoretical energy density that we've colored light blue on that chart. Our solid-state batteries will move through that inflection point there, and we'll be improving cycle life and power density as we move through to D8, which then translates into a minimum viable product, or MVP as it's called there, which also actually corresponds to our A samples. So the automotive industry refers to A, B, and C samples, where A sample is a product that meets a specification, but those cells are made on usually a small volume pilot line, such as the one that we're currently building at our facility in the UK. That will allow us to respond to RFQs, or requests for quotation. And then a B sample is a battery with the same specification as that A sample, but is produced on production intent equipment, but not necessarily in the volumes that you need in order to launch a vehicle platform. And that's when you get onto C samples. C samples are, again, the same batteries made on the same production intent equipment, but add volume. And then they give the reassurance that you can implement that process technology in a gigafactory. So we expect to make A samples on our pilot line in 2025. We will then transfer that technology to a scale-up facility that our partners will operate. As Jason explained earlier, we operate an asset light, or a capital light business model, where we license the technology to our partners to enable them to manufacture it at scale. And they will then produce B and C samples in their scale-up facility before implementing it in a gigafactory. So what does the competitive landscape look like? We always get questions about, who should we be paying attention to? Unlike Stereax, there are many developers of EV batteries, and actually it can be quite difficult to understand the differences between the technologies and the pros and cons of the different approaches. Actually, I've tried to reduce this competitive landscape into a simple 3x3 matrix. I've probably oversimplified it. Apologies to anybody out there who may feel that actually I've misled the audience by this simplified approach. But I think it sort of gives you an indication of some of the benefits and some of the drawbacks of the different chemistry choices that you can make. So we actually have selected a silicon anode and an oxide electrolyte combination, as I said at the beginning. There are others that have adopted this approach as well, as far as we can tell. But we feel that our approach has some benefits in that using a stable oxide electrolyte We have a very straightforward manufacturing process. It does actually make it slightly more challenging in order to make the cells, because you have to manage a greater interfacial resistance when you use oxides versus sulfides. But we believe that actually, if you can overcome that barrier, then it's worth it in terms of longer term use of the materials and ease of manufacture. Many companies are using a sulfide-based electrolyte. We actually believe that that is a very straightforward way to make a solid-state battery. You get high ionic conductivity, which means effectively you can transfer the lithium ions from one electrode to another in the battery, and therefore you get a higher charge and discharge rate, so a higher power density. Often the interface resistance is lower, but the problem is actually that sulfides react easily with oxygen and moisture, and you can end up with toxic gas releases, and therefore that increases the manufacturing cost when you use sulfides. So in terms of the support that we've got for our Goliath program, we are receiving support from the Faraday Battery Challenge. The program that we're running is the History program. This is very much our core mission. It is a 24-month collaborative program which started in February of last year and will run for just over another year. The ILIKA grant is 2.8 million. Actually, total program value was about 8 million. We've got 9 collaborative and steering partners, including an anode supplier, Nexion, that has developed silicon anode material, and some of the UK's leading universities, including the universities of Oxford and Imperial, St Andrews and UCL, and also an engineering company, HSSMI, who are delivering a full life cycle analysis of the battery production and materials, so that we can put more flesh on the bones of that recyclability claim that we have. And we're lucky enough to have both BMW and Fortescue WAE on our steering committee to help guide the program. Another piece of support that we've got is from the Automotive Transformation Fund, which is being managed by the APC, or the Advanced Propulsion Center. This is a program we refer to as SYSTEM, which actually just started in October. We are working together with the UK Battery Industrialization Center, or UK BIC as they're known, as well as a company called MPAC, to develop an assembly line for that 1.5 megawatt hour per year pilot line that we are installing at our facility, which is enough to deliver A samples. Actually, we just had a design review of this assembly line a couple of weeks ago, and that is coming on very nicely. So that program is well on track. And the idea of the UK BIC interaction is to undertake physical trials of electrode production at a much larger scale. So you can see by these interactions, what we're doing is we are de-risking the scale-up of the technology, so that actually we have a nice package of process technology to be able to license to our partners. And then when you look at the commercial interactions that we've got going, we actually are in discussions, pre-commercial discussions, with 17 companies. Over 80% of them come from the automotive sector, so either OEMs or tier ones, and then a further 18% who are non-automotive, so consumer appliance companies. In terms of geography, primarily here in Europe, 70% of them from Europe, but also companies from North America and Asia. So a strong portfolio of interactions, and we expect some of these evaluations to then turn into closer commercial collaborations as we progress through 2024. So now we've got a bit of a discussion of ESG, and I'm going to hand over to Jason to cover that as well as the financials.
Thank you, Graham. So ESG, or environmental and social governance, is very important for us at ILIKA. It's close to our core beliefs and our own activity around what we are doing, how we operate. But also it has a dual benefit of it is something that is clearly appropriately important to our potential customers, so in the automotive sector. So as they are larger companies, more regulated, and have additional requirements to report their own ESG positions, what we can see is that really there is a lot of synergy between driving our own position and ensuring that the products that we're developing and materials we're selecting, supply chain selection, make it as easy as possible to transfer our products into that automotive supply chain for the Goliath side and into the medtech supply chain for Stereax. So what we want to do is make sure that we are not passing a problem forward by choosing materials that are sourced from conflict minerals or that have challenges around recycling. So Graham already touched on with the history grant that we are working with partners around the recyclability of our batteries to make sure that both in our own development as a company, but in the products and processes that we can hand forward as part of that licensing activity, we can ensure that we really give a leg up to our partners to make sure that they are hitting the ground running. So that's part of trying to build that very strong partnership with those 17 potential customers or licensees that Graham talked about on the Goliath side, or with Certec and their ultimate customers on the Stereax side. So we're continuing to ensure that we maintain our ISO certifications. So we have completed recertification for 9001 and 14001, and we're continuing to assess the other elements of that and continue to push ahead with monitoring as we go forward, always trying to be ahead of the regulations that we're required to as a small AIM-listed company, but cognizant of the fact that we need to work within our financial constraints as well and do the appropriate actions at the appropriate time to further our ESG journey. Moving then to the financials, broadly in line with expectations, although slightly ahead, so slightly better than. So just touching from income down, the income very much derived from grant funding. As Graham said earlier, that is the history grant, which is over a 2-year period, and a small amount just started to come through from the system MPAC machinery grant that we have secured through the last year. Very much the history grant has been a little bit more front-end loaded than we expected. So while the total amount of 2.8 million to ILIKA out of a total of 8 million awarded for that total project has not changed, the phasing of it has been a little bit more front-end loaded than we expected. And that's why we would say that we probably expect that to slow down a little bit in the second half, because it is a finite amount that's been agreed as part of that grant project, and therefore will slow down. However, just to give clarity on that, we're continuing to secure and look for additional grant funding opportunities to keep that going, and we're in a number of conversations. As Graham said, we've got the history grant and have recently had the half project review with that, and we had some really good interaction, not just with the steering committee on history, but also with the wider APC team, who are looking at ILIKA to say, actually, what's the next journey, the next piece that you will go on. So that's really positive from our point of view. And as soon as we have more to update on that, obviously we'll keep that information flow coming. But at the minute, that income is around both history and system. So that then falls down. And as we look at the P&L and the cost base, we've taken some of the costs out of the business as a result of that Certec tech transfer and licensing agreement. So as we look at the administrative costs year on year, they're about £1.5 million lower than they were at this half-year point last year. And that really is due to being able to close down some of those really energy-intensive activities that we had around operating a clean room for some of the Certec related equipment that we've now sent over, and the Stereax processors. So that really has helped to reduce that cost base, and we've redeployed those people towards Goliath activity to help move the Goliath process on. So the combination of that increase in revenue and that reduction in cost helps then to fall to the bottom line. So the EBITDA loss has reduced, so 1.9 excluding share-based payments versus 4.1 at the same point last year. And both of those factors feed nicely into the cash balance, with the final piece of that puzzle being around our capital spend. So as Graham touched on the system grant, that really is about our scale up with manufacturing equipment. So a large piece of capital item that we are in the process of procuring to install for our A sample production scale, our 1.5 megawatt assembly line. Historically, we would have been forecasting that that would be a purchase of £1 million piece of machinery that we would be buying ourselves. Now, through the grant-funded project, we have been able to reduce that spend by half. So still securing the same piece of machinery needed for scale-up, but using the advantages and benefits that come with that collaboration with MPAC and with the grant funding authority to minimise the cash burn for ILIKA and to extend our runway further forward. So that leaves us at the half-year point up with 13.2 million in cash or cash equivalents.
So just to wrap up before we go into the questions, I think it's going to be a fantastic year for ILIKA. We've got scale of Stereax through that joint manufacturing and marketing relationship with Cirtec. We're going to mature our Goliath technology with some of the partners that we're interacting with that we've hinted at through defined technical milestones. And of course, we'll continue to push for further grant support along our development journey, and then in due course, commercial revenue through that partnering. Many thanks for your time today, and we'll move over to the questions now.
That's great, Graham. Jason, thank you very much indeed for updating investors. Ladies and gentlemen, please do continue to submit your questions just using the Q&A on the right-hand side of your screen, but while Graham and Jason take a couple of moments to review your questions submitted already, I'd just like to remind you that a recording of this presentation, along with a copy of the slides and the published Q&A, can be accessed via the Investor Meet Company platform. Graham, Jason, you've received a number of questions ahead of today's event and a number throughout, so thank you to everybody for your engagement. If I may, Graham, maybe just hand back to you just to moderate through those questions, and I'll pick up from you at the end.
Very good, thank you. So I'm just going to take them from the top here. First of all, is there any competitive technology known to you that causes concern as a potential threat? So I think in answer to that, we need to answer it in two parts. So first of all, on the one hand, for Stereax, it's a fairly sparse competitive landscape. There are not too many companies that are in a position to compete with the miniaturized USPs of Stereax. The incumbent medical device battery manufacturers have actually done their very best to miniaturize coin cell technology, but the disadvantage of doing that is that there's still quite a lot of parasitic weight associated with the can of the battery. So you can imagine all of the active materials are inside a miniature can, and by having that stainless steel can, that adds quite a lot of additional weight and takes up a lot of volume that otherwise could be used for active materials. So we believe that by having our Stereax active materials deposited onto a glass substrate, that we've got an intrinsic advantage there. In terms of Goliath, on the other hand, of course, there's a more extensive competitive landscape, and we've done our best in one of the slides that we looked at earlier to try and make it clear how that landscape is segmented. We believe that actually we've got some pretty compelling USPs for our technology. And actually what I would say is that we believe the competitive landscape is unlikely to be dominated by one solution. I think history would validate that conclusion. If you look at the existing lithium-ion battery market, there's quite a lot of diversity, mainly driven by choice of materials for cathodes, but also actually in different types of electrolytes and also for the anodes. So for instance, most of our consumer electronics is powered by LCO batteries, or lithium cobalt oxide batteries, whereas for vehicles, actually many people either use NMC or NCA or LFP chemistries for those batteries because of the different characteristics that using those materials confers. And I personally think that that's likely to be the same for solid state. There are different solutions. There's semi-solid state, which use a high polymer content. There's full solid state batteries that use sulfides, and others that use oxides. And then, of course, you've got the choice between silicon and lithium anodes. So all of these different choices give different properties to the batteries, and I think we'll find that the applications then drive the uptake of those different cell architectures. So the next question I've got is, are the above companies buying any of your products? I think the above companies refers to some of the companies that we have named as being collaborators in our grants. So, in the past, we have done Faraday Battery Challenge grant-supported collaborations with McLaren and Jaguar Land Rover and Honda Europe. And of course, in the history program that we're currently doing, we have BMW and Fortescue WAE on the steering committee. Actually, we have a portfolio of 17 evaluation agreements in place, as we've mentioned during the presentation, and those companies are interacting with us on a pre-commercial basis. So they're evaluating the properties of the batteries, evaluating the data that we're sharing with them, and coming to a conclusion as to whether our technology is complementary to the technologies that they already know about and are evaluating. And you can expect further progress with those relationships in the course of 2024. The next question is, when do you expect first revenues to be incoming? Well, of course, the company is recognizing revenue at the moment from the grant support that we are receiving, but also we are expecting to receive product-based revenue. And Jason gave quite an extensive discussion on other sources of revenue too. So in particular for Stereax, some of the licensing revenue, NRE, and manufacturing revenue associated with electrode manufacturing that we're still going to do. That will build up in the coming years, and we expect that most of that revenue will start to be generated from 2025 onwards for Stereax. For Goliath, the near-term revenue, in addition to the grant revenue, is likely to be licensing. And the reason actually that companies will interact with us on that basis is that it's important that they get access to technology in order to start planning their scale-up. So by partnering with us and taking a license, initiating that tech transfer, they start to plan their own scale-up activities in a timely fashion. So, it wouldn't surprise me that in the course of 2024 that we see licensing revenue from those interactions. And then, of course, there is the sale of initial prototype product, and that product will be ready for commercial release mid-year. That's our P1 prototype. So you can see that there's a number of revenue streams that will start to build as we get through the remainder of 2024 and into next year. Let's have a look at the next one. So there's a question here. What would be a typical or estimated time once customers have received M300 batteries and sales to those customers. So I think this question relates to how long would it take for revenue to start flowing to Cirtec and ourselves once customers have committed to the M300. And the answer to that is that actually, as soon as we start to deliver cells to customers, then there is revenue associated with that. Last year, when we shipped prototype M300 batteries to customers for their initial evaluation, a lot of that was done on commercial terms, and there was income from that. And we expect that once we have the new line up and running, that actually revenue will flow from the supply of batteries to customers. And the reason for that, of course, is that as we go through the regulatory body approval process, or as our customers go through that process, they need increasing volumes of batteries. And so they will start to buy initially, quantities in the hundreds, but then in the thousands and then tens of thousands as the size of the trials and the testing increases and as they get close to market. So it's not the case that you need to wait till the end of the approval process before we start generating revenue. That will ramp up gradually over time. And that's actually quite useful for us because there is a need to, of course, invest in the equipment to ramp up the volume of production. And therefore, we don't want a massive step change in demand that makes it difficult to match in terms of supply. We would rather ramp up gradually and start to generate revenues that can feed back into the business. Typically, the full FDA approval takes between 3 and 5 years, depending on whether the product is a Class 2 or a Class 1 device. And actually, we have a portfolio of different devices that we are supplying batteries for. And that means that actually we have a nicely balanced revenue profile that Jason talked through earlier in the presentation. So we've got another question here that seems pretty popular. How does ILIKA Goliath batteries compare with Northvolt's sodium-ion batteries, which contain no lithium, cobalt, and nickel, etc.? I asked this question in light of UK internal limited access to rare earth materials such as the above and Chinese dominance over lithium. So yeah, it's an interesting question. That so sodium-ion batteries are likely to be most useful for stationary storage. So they're not expected to have high enough energy densities for them to be useful for automotive applications. Sodium is a much heavier material than lithium. So the energy density of sodium-ion batteries is significantly inferior to the lithium-ion equivalent. So while they may be less expensive, they are primarily useful for things like UPS, so backup power, in particular to, say, telecommunications masts, and maybe in some examples for off-grid storage. So yeah, it's a different type of technology and not really a competitor to the markets that Goliath is designed for. Let's have a look at the next question. So the question says here, you seem to have adjusted your language describing your products as addressing areas where conventional batteries cannot be used. Does this indicate that you are not targeting the next generation of existing batteries, particularly in EVs, but only aiming at new markets? No, I think that this is just a misunderstanding of language. I think most analysts would agree with me that solid-state batteries are expected to be the natural successor to traditional lithium-ion batteries for EVs. Just about all OEMs have got solid-state batteries on their roadmaps, and they're looking to engage with companies to access technology that enable that transition. So certainly from a Goliath perspective, those batteries are very much designed for EV applications. So another question here, are there any plans to develop another product in the Stereax line other than the M300 battery, assuming the M300 is successful? Yes, so in fact, Cirtec and ILIKA are collaborating with each other in order to develop our next product, which is the M1000, which is a higher energy density device with a capacity of 1 milliamp hour, as opposed to 0.3 milliamp hours, which is the energy capacity of the M300 battery. And then we have a roadmap of custom designs that we will be working on together with OEMs in order to develop batteries for specific applications. So there's some really interesting opportunities that we'll be addressing in the coming years. So there's very much a continuous R&D roadmap with a series of launches over the coming years.
If I jump in with one, give Graham a chance to recover his voice. So there's a question here. The timescales to progress from A to C samples seem lengthy, almost 2 years from A to B. Does that raise concerns that you arrived too late to the party compared to the competitors? And could this be significantly accelerated with increased funding? So the timelines, as we've shown it on the graph in the presentation, are really derived through conversation and engagement with the automotive partners. So we're doing a lot of discussions with them on what their own timescales look like, because it's not just the development of the battery itself, it's also the pack design, as those batteries need to be designed into a pack that makes the most of their particular USPs, as Graham talked earlier, in terms of the benefits of solid state batteries, allows you to adjust the engineering that goes around the pack to take the most benefit to the EV as a whole, whether that's in range or weight or charging time. So there's a lot of other activity that will go on with the partners, whether that's through the tier one manufacturer, who also needs to consider their scale up of an implementation at their existing gigafactory. So introducing solid state into one of their production lines within a gigafactory, or it's at the automotive side where they need to design the pack and then design that into the vehicle platform that will then form the basis for their future generations of EV. So although the timescale looks quite long, that is aligned with the current expectations that the automotives have given us in terms of how long it takes for them to do that development themselves. So there's a lot of work that goes on between developing the battery to then actually seeing that car on the forecourt with an ILIKA battery in it. Although, as Graham said, revenues would start to flow as we're delivering batteries. So all of those A, B, and C samples would drive revenue for ILIKA. Just you would see a little bit of delay to that car being on the forecourt, as it has to go through those steps and for all those design pieces to be done by each of the partners.
Thanks, Jason. I've got another question here. The Mercedes CTO recently stated that SSBs wouldn't be a major breakthrough as conventional cells are getting so much better, and SSBs wouldn't offer a major cost or energy advantage. And BYD is also ditching pouch cells. How can investors be assured that Goliath will actually be better than current or competing technologies? So I think many CTOs wouldn't agree with the Mercedes CTO because actually there are significant advantages to taking an SSB approach. I would, however, agree that conventional cells are getting better, but not significantly. we showed the energy density increase that is possible for conventional lithium-ion batteries, but realistically, we are at the end of that technology S-curve. Lithium-ion batteries have been manufactured for a number of decades now, and they're starting to reach the end of what is theoretically possible with that approach. So solid state really offers a lot of advantages, not only because of the intrinsic higher energy density that they can deliver, but also actually because of the improved safety, which means, as we were talking about earlier, that the pack design can be lightweighted, and therefore actually there are vehicle level advantages. So I think you needn't worry about solid state batteries not being a technology that is matured. It will definitely be the case that that technology is a major feature on OEM roadmaps as we go forward.
I jump in with another one. So question here, Northvolt secured a European innovation grant recently to ward off American funding through the benefits of the Inflation Reduction Act and ensure Europe can keep Northvolt battery factories in Europe. Is the European Innovation Fund a potential avenue for ILIKA, as it seems there's little UK government funding into battery scale-up in the UK? So we've already mentioned that actually ILIKA has had quite a bit of funding from the UK government through the Faraday Battery Challenge, and that's a reflection of our progression as a company through the various TRL, so technological readiness levels. And as we move up in terms of that level, we then move into larger and larger grant funding opportunities. So as I mentioned earlier, when talking about the history project, we're now at the point where we would start to discuss around the APC, Advanced Propulsion Center funded projects, which are much larger in scale, and they are very much there to support the transition, the commercialization of British innovation into real products. So that would be about the development and implementation of ILIKA's batteries into mules or demonstrator vehicles to be able to demonstrate them operating to help us move forward, but also to help demonstrate to those partners, those automotive partners, that the technology is viable within a physical demonstrator. So I think it's fair to say that actually that there is funding out there, and we've got a good track record of being able to secure that and continue to engage in those conversations. So hopefully in the future, we'll be able to bring that positivity back to you again through further announcements. But as nothing is secured at this point, we can't commit to what we can or can't say is going to happen in the near term or medium term future.
There's a question here. At what stage will the company seek external investment into Goliath development and Scaleup? I think that's an interesting question. As we've mentioned in the course of this presentation, we are in pre-commercial discussions with 17 commercial partners, and it is not unlikely that a subset of those will want to participate either through licensing agreements or equity investments in our journey. So I think that is a potential news flow for the course of 2024. And I think that type of external participation from the industry would be further validation of the work that we're doing and would augment shareholder value as we proceed along our roadmap. There's a question here. Does your choice of anode, cathode, and electrolyte limit the applicability of Goliath to certain markets compared to other SSP developers? So I think the answer to that is no. Actually, we feel that choosing an oxide-based electrolyte is a very robust choice and opens up all sorts of different applications. I think the proof point of that is the fact that we have some consumer appliance companies that are approaching us and wanting to do further evaluation of the technology. I think the silicon anode is a very approachable solution. And from a manufacturing perspective, we're certainly seeing advantages relative to using metallic lithium. I think one of the other disadvantages actually of using metallic lithium is that it's a very lithium intense choice, and therefore quite a costly choice in terms of overall cell cost. No, I think the market applicability of the Goliath technology is pretty broad. I think I'm just looking at the time now. We've had just over an hour of presentation and questions. So I can see that there's a few more questions still stacked up. I suspect that we'll exhaust each other before I get to the end of those verbally. So what we'll do is we'll take a look at those after the call, and we'll do our best to answer them and then post them in due course.
That's great, Graham. Jason, thank you once again for taking your time to go through those questions. And of course, we will make those questions available to you post today's meeting. Graham, thank you for your time. And Jason, I know investor feedback will be important to you both. I'll shortly redirect those on the call to give you their feedback, but wondered if I may, Graham, just ask you for a couple of closing comments.
Yeah, thank you very much to everybody for taking the time to listen to this update from the company. I really appreciate your interest and actually your continued support for ILIKA. And it's been a very vibrant and engaged Q&A session. I hope we've given some additional insight into the company's priorities and efforts as a result of that Q&A session. And I very much look forward to the next opportunity actually to give you an update on our progress.
That's great, Graham. Thank you very much indeed. Could I please ask investors not to close this session, as we now automatically redirect you for the opportunity to provide your feedback in order that the company can better understand your views and expectations. On behalf of the management team of ILIKA PLC, we'd like to thank you for attending today's presentation, and good afternoon to you all.